So I just realized that I thought I was recording for these first two problems and I wasn't. That's always fun. So for number 1 and 2, we use the Pythagorean theorem for these two questions. It says, do these lengths form the sides of a right triangle? Well, we know if these did indeed form the sides of a right triangle, then it would work in the Pythagorean theorem. Remember, C is always got to be the longest or biggest side, so I put the 4 there. I plugged this in to my calculator and found that this does equal this, 16 equals 16, so my answer is yes. In number 2, again, it tells us we have a right triangle. Angle C is the right angle, and we're given two sides, 10 and 12. We're asked to find the third side. In this case, it's the hypotenuse, the C value. So we leave that as our variable. Plug it all in. Take the square root of 244, round to the nearest tenth, and we get 15.6. Okay. All right, so for number 3, though, notice the difference here. It asks us to find a side of a right triangle, but we're not given two sides. Instead, we're given a side and an angle. That's when SOHCAHTOA comes to the rescue. It's like a superhero. SOHCAHTOA. So if we're using this angle, 32 degrees, we're going to label this side opposite, and always across from the right angle is our hypotenuse. So which one uses O and H? Sine, right? So sine of the angle, 32 degrees, equals opposite over hypotenuse. When we're looking for a side, remember that's when we set up a proportion and we cross multiply. Okay, calculator, 600 times sine of 32, and we get 317.95. What does it say? To the nearest foot, so 318 feet. Lovely. Moving on to number 4, the difference here is that we're asked to find an angle. Remember these buttons on our calculator, second sine, second cosine, second tan. Those are read inverse sine, inverse cosine, inverse tan. Those are the buttons we use to find angles. Okay, so since we're looking for an angle, we circle the angle, right? That's where we're standing, right? And we label the sides from that angle that we're looking for. This is opposite, and this is next to or adjacent. So which function uses O and A? Tangent. So tangent of that unknown angle equals 3 over 5. So to undo tan, so to speak, we do inverse tan on both sides. That undoes the tan, so we're left with x. What you do to one side, you do to the other. Golden rule of equations. So inverse tan of 3/5, and you get, to the nearest degree, 31. I'll show you quickly. Second tan, 3 divided by 5, enter. There it is. If you're not getting this, you want to check your mode, right? Check your mode. Make sure you're in degree, not radian. Okay. Alrighty. So let's go on to the back here for a moment. I'll post all of these answers. For these next two, it just says evaluate the following. So you just type that into your calculator as you see it. So cosine 84 degrees. What am I doing? Let's try that again. Cosine 84, it's like, there we go. To the nearest 10 thousandths. It goes tenths, hundredths, thousandths, 10 thousandths. All right, so this next one, just type in sine of 21, enter, and we get 0.3584. Okay. The difference with 6 and 7, this is asking for the ratio of sides. This is asking for the angle, right? What comes after the function is the angle. So recall that if we're looking for an angle, we use our second sine, second cosine, second tan buttons. We call those inverse buttons. So just do second tan of this number, and you get 74. Second cosine of this number, and you get 32 to the nearest degree. Alrighty. Find the missing side in the triangle below.
Well, Mommy,
Yes, dude? Okay, time to break.